In this video, we're going to be talking about DMPG 2015 S5 black and white. So in this problem, we're basically given an empty grid that looks like this, right? So basically, the board consists of n by n squares of unit dimensions on a plane. And it's defined as the topmost point as 0, 0. And originally, everything is colored black like this. Now, basically what the person's going to do is Ruby is going to execute a few commands. And those commands are specifically going to be changing whether or not something is going to be black or white. So if they decide to, update this rectangle here, the entire rectangle, then what's going to happen is because it was originally black, it becomes white. And so you can see in this example, they update from 0, 0 to 10, 10. So they're updating the entire grid from 0, 0 all the way to 10, 10. So they update this entire thing. Then basically, they update from 2, 2 to 6, 6. So they update from here to here. So you can kind of imagine before this black square was here, everything was white. But then because they flipped all these squares here within this, between here and here, then we know that these are going to become black. So if we look at this example here, there's a bunch of different operations or queries that have been performed. And you can see that the ending result looks like this. Now, what the problem is finally asking you is it's asking you how many of the cells, right? Each one of these are cells, are colored white. So the way we're going to do this problem, and the first way we could do this is a naive approach. The naive approach is quite simple. We have our grid, and we basically update all values or all the cells between 0, 0 or x and y and all the way to the bottom right corner. So we update like a rectangle of the values. Now, that's going to take a long time considering if at the worst case, we have to update every time from 0, 0 to n. And in that case, what's going to happen is our time complexity for updating is going to take O of n squared time. And because n can go up to, let's see, 10,000, then we know that 10,000 squared is already way too much, right? This is 1, 2, 3, 4. It's kind of fine, but then we have to think about that we have to do m operations, right? So multiplied by another 100,000, that's way too many operations that we have to do. So what we're trying to look for is some kind of O of m solution, right? Each query takes O of 1 time, and then maybe add on to a little constant like an n squared or something. So we already have the prerequisite knowledge to do this. And the way we're going to do this is by using something called a 2D prefix sum array and difference array. So using the difference array, we can update a range of values. And then finally, using the prefix sum array, we construct the original array and count how many of these are white. Now you might be wondering, well, what are we updating? What are we trying to add on to a specific value? Well, what we're going to do is we're going to simply add 1 to the range of the rectangle. So say we're updating this rectangle here, well, we're just going to add 1. And because we know that it starts off as black, if we think about it as this way, if we update the same cell 2 times, then it becomes first from black to white, then white to black. And so you can see that if it's an even number of operations on a certain cell, then it's going to be black. If it's odd, then it's going to be white, right? So you see how these cells around have only been updated once. The black cells here have been updating twice. So once we construct the prefix sum array of the difference array, giving us the original array, we are pretty much going to have to count in O of n squared time how many of these cells are white. Or in other words, how many of them mod 2 is equal to 1, right? So we can actually write this up. So here I already have my buffered reader, fast IO stuff already set out. So the first thing that they want us to do is take in an integer n and m. So this is the size of my grid. So it's n by n. And then the number of operations that I have. So we have n here. And we have m. From there, what we need to do is we need to create a difference array. Now, one little thing about this problem is the time limit is a bit small for an n squared here. And, or sorry, not the time limit, the memory limit. We are only given 256 megabytes for 10,000 times 10,000 integers, and that's not a lot. So what we have to do is we actually just need to cut it down by a little bit and use another data type that's smaller than an int, like a short. And so that's going to be my difference array. So static short, difference array like that. And then basically all I need to do is say diff is equal to new short size n plus 5 by n plus 5. So that's basically going to create the difference array for me. Then what I need to do is I can simply perform all the operations. So if you remember in the prefix sum array, how do we update a range of values using the difference array? Well, it's actually quite simple, right? All we need to do is 4 minor steps. And I'll first take in the input. So we have an x value, we have a y value, we have a w value, and we have an h value. From there, we notice that these values of x and y are 0 indexed. So what I'm going to do is I'm actually going to add 1 to each of them so that they become 1 indexed. And in that way, basically what's going to happen is w and h are not actually the right corner coordinates. They're pretty much like how much do you need to expand it by, right? So it's going to be w plus h. So in that sense, we need to just add 1 to the x and y here. Oops. So now to update the range, we say diff xy plus plus, or you can kind of think about it as adding a constant. So plus equals 1, for example. And this number can be c, any value. So then we update this part, and actually we subtract 1. The reason we subtract 1 is because we want to, if you remember in the 2D prefix sum array video, we want to remove that yellow part. Next, we need to update this part, and then finally we re-update some of the parts because if you recall correctly, some of the rectangles are unupdated twice, right? The next thing we need to do is count the number of rectangles that are going to be white. So we say long count is equal to 0, for example, or I'll call this white count. And all we need to do is we just say, go through each of the rectangles in O of n squared time. Very simple. And to construct the regular prefix sum array, I'm not going to reconstruct it. The reason I don't want to reconstruct it is because you can actually reconstruct the prefix sum array in place. And what do I mean by that? Well, all you need to do is say diff of ij plus equals diff of I minus 1j plus diff of ij minus 1 minus diff of I minus 1, j minus 1. So think about it in this way. Diff ij is my current value, right? That's my current value. And to construct the prefix sum array of it, it's kind of the same thing as saying this. PSA ij is equal to diff ij plus diff all that stuff. Now, this value, right, all the other next values depend on the prefix sum array, right? So what we do is we can just say diff of ij is equal to all of this, and it'll give you the same value. Now, one little issue is that you're going to have provided an int here. So what we want to do is just write plus equals, and that'll work perfectly fine. Now, say this is my current cell value. Now I just need to check whether or not this is even or odd. So if it's even, it's very simple. So, or sorry, let's say if it was odd, for example. So diff ij mod 2. Now actually there's a little issue with this. The issue with this is that this value can, let's see. Yeah, so when we overflow, what we want to do is we want it to mod a negative value. And the way we can mod a negative value is simply by saying this. And 1 is equal to 1. So what does this mean? If you haven't studied any bitwise operators yet, I strongly recommend you studying it. The reason we do and 1 here is just to check whether or not the number is even or odd. You can kind of think about it in this way. You're just checking whether or not the first bit is a 1. And if it is a 1, then it's an odd number. Otherwise, if it's a 0, it's an even number. And so all we're doing here is we're just checking whether or not the first digit or the first binary 2 to the 0 is equal to a 1, right? The coefficient. And so here we can just say white count plus plus. So this is a little trick to checking whether something is even or odd. And if you haven't studied in bitwise operators, there's going to be a video on bitwise operators as well. All we need to do is finally print out the white count. And so let's run this and see whether or not we get the sample input correct. So it's running. Oh, let's see. So right here, this should be a Y. And let's run it. And we get 58, but it should actually be 64. Okay, let's check out where we went wrong in this code. Okay, so here we're saying plus equals diff of I minus 1j, diff of I j minus 1, minus diff of I minus 1, j minus 1. Then all we need to do is check whether or not that is a 1 there. I guess what we could do is check whether or not this is greater than 0 and see if this works a little better. Okay, so let's see. 58 still. Okay, so the way we can actually debug this is we can actually just print out all of the values. And of course, we can check the value modded by 2. Or in this case, like this. So what we're going to do is we're going to say if diff of ij and 1 is greater than 0, then we're going to print out w, for example. Now otherwise, we know that it's black, right? So this is odd. This is going to be even. So print out a b. And then finally, we want to print out a new line every time we debug. Okay. So let's take the sample input here. And we can see that some of the values actually didn't get updated correctly. Okay, so it's most likely in this prefix sum array part of the operations. And so we're going to look at exactly where it went wrong. So we can see that we input W and then H. We added 1 to each of these. And here, I'm actually going to just change these to plus plus. So diff xy plus plus, xy plus h minus minus, just so that it's a little easier to debug. Oh, and this should be a y. And so I don't think the other parts should matter really, but just to show you that it doesn't have to be plus equals, I'll do that. From there, we can delete this now, and I'm pretty sure this should work now. So this should give me 64. Cool. And over here, 54. Cool. So let's submit this in Java 8. And as you can see, it works perfectly fine. So in this video, you learned about how to solve DMPG 2015 S5 black and white.